Hey, what's up? It's your old pal, Mr. Cook, and we are going to work on the Unit 5 test review. And we have our little formula sheet over here. Just got to make sure that we know how to use it. All right, so here we go. I have a calculator ready and also something to write with, and this will be pretty easy. Now, we got to determine whether the series is arithmetic, geometric, or neither. If arithmetic, lists the common difference. If it's geometric, lists the common ratio. So if it's arithmetic, it keeps adding or subtracting by the same number. Geometric means that it keeps multiplying or dividing by the same number. Neither means something else happens. So with 1, 3, 5, 7, 9, it keeps adding 2. That's our common difference. And that means that it's arithmetic. From 3 to 6 to 12 to 24 to 48, it keeps multiplying by 2. So that means it's geometric. And the common ratio, R, is equal to 2. From 2 to 4 to 9 to 16 to 25, well, this is almost all the square numbers except for 2. But obviously, they're not adding by the same number. They're not multiplying by the same number to get to each individual value. In fact, this is adding 2, this is adding 5, this is adding 7, adding 9. So like it keeps changing up each time. So it's neither. You don't have to do anything about it. Just leave it. Okay, next. Find the common difference, the explicit formula, the recursive formula, and the 52nd term. If you look close, you actually know exactly what kind of relationship this is. Because if it says common difference, that means it's arithmetic, right? So with the arithmetic formulas, we already know the explicit form, which is what we need to find, and the recursive form, which is what we need to find. So the only other thing that we need that's not on here is the 52nd term. So let's find the common difference first. The number keeps adding or subtracting each time. So from negative 29 to negative 39 and negative 49 to negative 59, it keeps adding on negative 10. So negative 10 is our common difference. Now let's write up an explicit formula. So we use the template here. AN is equal to A1 plus D times N minus 1. Right, so that's all this. We need to know what that means. A1 is the first term. What's the first term in the sequence? Negative 29, so negative 29 goes there. D is the common difference, which we know is negative 10, so plus negative 10 is the same as saying minus 10, so minus 10 and minus 1. And some of your teachers may ask you to distribute the negative 10 in. I don't, so you can just leave it like that for me. If you have to distribute it in, then you distribute in the negative 10 and you get negative 29 minus 10n, and the negative 10 times negative 1 is plus 10. Negative 29 plus 10 is negative 19. So it's negative 19 minus 10 and would be your formula. I don't make my kids do that, so I just leave it like this. So that's all that you would have to do if you're in my class. Next, we got to find the recursive formula. So recursive formula is right over here, so I'm just going to write it down. AN equals AN minus 1 plus D, and then A1 equals first term. So some number. So the only things that you need to write in are the common difference and that first term number. So the first term is negative 29. So write it in, negative 29. The common difference is negative 10. So adding negative 10 is the same as saying minus 10. So just like that, I have the recursive formula. And I have the explicit formula. All I need to do now is find the 52nd term. So anytime that you need to find the 52nd term or the 1/1,000,000th term or the 38th term, you use the explicit rule, okay? Always use the explicit rule, not the recursive rule. Because if you want to use the recursive rule, you have to find like the 51st term, the 50th term, the 49th term. It's always based on the previous term. So for this one, just plug in 52. So, for the formula, A52 is equal to negative 29 minus 10 times 52 minus 1. Then just let your calculator do the rest of the work. So let's see here. Negative 29 minus 10 times parentheses, and then 52 minus 1 is 51. So I get the 52nd term is negative 539. And there's my answer for that one. All right, that's number 2. I'll probably go through the first 5 problems and then make a new video or something. Yeah, because that goes on to geometric, I think. Yeah, okay. So 3. Given the explicit formula for an arithmetic sequence, so that means that I have this right now. If find the common difference, the first 5 terms, and the recursive formula, and the 52nd term. Well, the common difference is easy. It's the number that's on the n value. So the number that's on the n value is -2. So the common difference is -2. Easy enough. Now, find the first 5 terms. So to find the first 5 terms, you really just have to find the first term. So to find the first term, you plug in 1. 13 minus 2 times 1. 13 minus 2, that'd be 11. So 11 is my first term. Then the common difference tells you to go down 2 each time. So 11 minus 2 is 9. 9 minus 2 is 7. 7 minus 2 is 5. 5 minus 2 is 3. And you can keep going with it if you want, but they just want you to find the first 5 terms, so there they are. Next, we need to find the recursive formula. So the recursive formula is just from this formula over here. So it's an equals an minus 1 plus the common difference, and then a1 equals some number, the first term. Well, the good thing is that I have the first term. It's 11, so this is just an 11 here. And then I need the common difference, which I already know is -2. So -2 goes right there. There's my recursive rule. There's my first 5 terms. There's my common difference. The last thing I need is the 52nd term. So the 52nd term I find by plugging into the explicit rule. So if I plug in 52, A52 is equal to 13 minus 2 times 52. And then I just plug it in. So 13 minus 2 times 52, and that gives me -91 for my answer. So there's the 52nd term. Okay, moving on to the next one. Given the recursive formula for an arithmetic sequence, so that's recursive and arithmetic, so that's this thing that they're giving us. Find the common difference, the first 5 terms, the explicit formula, and the 52nd term. Well, the common difference is d, and that's the number that's adding on to the an minus 1, so that's 4. So d equals 4. So that's pretty easy. Then to find the first 5 terms, they already give you the first term right here, -1. And then the common difference is 4, so just keep adding 4, because you know it's arithmetic. It keeps adding the same number each time. So -1 plus 4 is 3. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 4 is 19, and so on. But we only need the first 5 terms, so there we go. Next, the explicit formula. So the explicit formula, I need this formula here. So let me write it down. an equals a1 plus d times n minus 1. So I need the first term, which is -1. I need the common difference, which is 4, so plus 4. And there's my equation for the explicit rule. Now I need to find the 52nd term. And remember, when you need to find the 52nd term, or whatever term number, just plug it into the explicit rule. So I'm going to plug in 52 for n, so a52 equals -1 plus 4 times 52 minus 1. All right, and then calculator time. So let's see here, -1 plus 4 times 52 minus 1 is 51. So that gives me 203. There's my 52nd term, and I'm all done with number 4. Now let's move on to number 5. For my money, this is the toughest problem in the on the test and on the review. So I'm going to put a star next to that, and we're going to do a whole video on that one. So I'm going to stop here on 1, 2, 3, and 4, and then we'll do 5 all by itself, and then close it out. All right, so that's it for this one. See you on the next video.